This session is for OCR FP2. The topic is integration, reduction formula, and we're looking at question 6 from June 2011. So let's just start by looking at the question. So we have I of n is given as the integral between 0 and 1 of x to the n upon 1 minus x to the power of 3 over 2, and that's for values of n greater than or equal to 0. So in part 1 we're asked to show that I of n is equal to 2n over 2n plus 5 times I n of minus 1. So we've got this recurrence relation to show. And in part 2 it then says, hence find the exact value of I3. So 10 marks in total for the question, 6 marks for this first part, so let's have a look at that. So the first thing that we're going to do is use integration by parts to do this integration. So we'll let u equals x to the n. So du by dx is equal to nx to the n minus 1. And then dv by dx is equal to 1 minus x to the 3 over 2. And so v is equal to minus 2/5 1 minus x to the 5 over 2. So just get your integration by parts correct. And then that means using that now we can say that I of n will be uv, so that's minus 2/5 x to the n upon 1 minus x to the power of 5 over 2, and that will be evaluated between 0 and 1. And from that we're going to subtract the integral of v du by dx. So that's minus 2/5 of 1 minus x to the power of 5 over 2 times nx to the n minus 1. And again we're evaluating between 0 and 1. Now of course if we substitute in the limits here, if x is 1 then this term will be 0, and if x is 0 then this we'll be multiplying by 0 here, so this actually turns out to be 0. So we're then left with these two minus signs will give us 2/5 of n. If I take that outside the integral sign, then we have x to the n minus 1 times 1 minus x to the 5 over 2. And the trick here is to see that we can actually split that integral and write it as 2/5 n x to the n minus 1 times 1 minus x to the power of 3 over 2. Now that's the bit that we had in the question, if you remember. So that was I of n had to the power of 3 over 2. But of course if we've taken that out we will still need a 1 minus x in there. So all I've done is I've rewritten it. But the advantage of rewriting that now is that if we multiply out, then we're going to have 2/5 of n times x to the n minus 1, 1 minus x to the power of 3 over n. Well, that's just I of n minus 1. And then we've got a minus x times that, which is going to be I of n. So we're going to have minus 2/5 n times I of n. So just check that you can see that just literally by multiplying out by this bracket you'll have one lot of I of n minus 1 minus x lots of x to the n minus 1 gives us x to the n, so that's going to be I of n. And in both cases we have a 2/5. So we're making progress now, and of course remember we know that that is equal to I of n. So if we just try and simplify that now, and we do have the result but we'll have to show it carefully. So we've got to that sort of stage. So all we need to do now is to bring all the terms involving I of n. So we've got 1 on the left, and we've got over here we've got we'll now have 2/5 of n and on the right we have 2/5 n in minus 1. And if we just sort of simplify that and keep working through, but it is a show question, so we'll just do it here carefully. So that's going to be 5 plus 2n over 5 equals 2/5 n in minus 1. And that, if we now just divide through, that's going to give us 2n in minus 1 over 2n plus 5, which is the result that we're looking for. So if we consider how there were 6 marks for this question, so if we just have a quick look at how those marks are awarded, then going back to this part here, then you got a method mark for using your integration by parts, and an accuracy mark here for completing it correctly. You got an accuracy mark for using your limits to find that this was equal to 0 and simplify that. A method mark for seeing that you had to simplify and multiply out these brackets here, and an accuracy mark for getting to this stage. So actually you had 5 marks by the time you get to that stage, and then you just had 1 final mark for putting it in the correct form. So that is part 1, and then in part 2 we're asked to find the exact value of I3. So using this recurrence relation that we have, we just established that in part 1, so I've just written it up here. Then we now need to work out what I of 0 is. So I of 0 is going to be the integral between 0 and 1. Well, x to the 0 is just 1, so it's 1 minus x to the power of 3 over 2. And if we simplify that, then we get minus 2/5 1 minus x to the power of 5 over 2 between 0 and 1, and that turns out to be 2/5. So we work out that I of 0 is equal to 2/5. I of 3 is what we need to know, but we're now going to use the recurrence relation that we have up here. So I3 will be 2 times 3, which is 6, over 6 plus 5, which is 11, times I2. But in turn, I2 will be 4/9, so 2n, 2 2s are 4, 9ths of I1, which in turn will be, if we just keep working through it, then I1 is going to be 2n, so 2 over 2 plus 5, which is 7, lots of I0. And of course we know that I0 is equal to 2/5, so we evaluate that and we get our answer to be 32 over 1155. So we were asked for the exact value, so the answer should be in fractions. So again, 4 marks for that question. So if we just check quickly, we get 1 mark here, a method mark, for working out the value of I0. We get a method mark for all 3 terms here using the recurrence relation, and an accuracy mark for getting the 3 correct. And then we get a final mark at the end just for our final answer. So 10 marks in total for the question. So don't forget, if you want to watch further revision sessions on video, then you can do that by going to the Further Maths Support Programme and following the link.